Good morning, students. I would like to welcome you to the class of mathematics. Today we are going to discuss about logarithm. Okay, before starting, I would like to remind you, make sure you subscribe on my YouTube channel, what we call Sanfaumi Online, in order to get more tutorial videos concerning the mathematics subject. Okay, by starting, you have to know the definition of logarithm or the meaning of logarithm. So what is a logarithm? Logarithm is another method of expressing the exponent. So there is something called the exponents, and the logarithm, this is another method of expressing that exponent. This exponent mostly obtained when you're writing the number in a power form. For instance, suppose you have 8. This 8 in a power form, it will be 2 exponent 3. This is a 8 expressed in terms of power form. But what is this 8? This 8 is a product formed after taking these 2 exponent 3. So this 8, I can call it as a product. Let me call it a product P. And this 2 is a base as usual. I think you know it. This is a base, and this 3 is what we call the exponent. So when we write a number in power form, we must have the product, and also we must have the base, and also we must have the exponent. So this exponent can be expressed in terms of logarithm. Okay, how can I express this exponent in terms of logarithm? Will be like this one. Always we're supposed to write log, then here we're supposed to write the product, and here we're supposed to write the base is equal to your exponent. This means exponent can be expressed in terms of logarithm, as you see here. This is a logarithm. Okay, so for that questions will be like this one: log product. What is a product? Our product is 8. Base, what is base? 2 is equal to exponent. What is exponent? Exponent of 3. That's why instead of writing 8 is equal to 2 exponent 3, I can write log 8 base 2 is equal to 3, like this one. Log 8 base 2 is equal to 3. This means hii 3 ambayo ilikuwa exponent nimeweza kuibadilisha kuweka kwenye mfumo wa log. Kwa hiyo kumbe exponent 3, which is exponent, it can be also expressed in terms of logarithm, right? Yeah, hivyo ndivyo tunavyofanya. That why tuna convert exponential form into logarithm form. Hebu tuone kwenye notes. Okay, let us refer from our notes here. Logarithm, a is equal to b exponent c. This a is what we call the product. Product how? Because it is obtained from the b exponent c. Hili ni zao linalopatikana baada ya kuchukua b exponent c. Okay, but this one is a product, this one is a base, this one is exponent. It's the same to this one. In terms of logarithm, we have to write log, then product, then opportunity tunaandika base is equal to exponent. This means hii exponent tumei express in terms of this form kuja kwenye format hii. That's why tunasema logarithm. This is another way of presenting or expressing the exponent. Very simple like that. Okay, and always you have to note, always logarithm must be written in this form. Log, here is a base, then here we're supposed to write the product is equal to exponent. That is a format of writing logarithm. Always must be there. But don't forget the format of writing the exponent. When you need to write the exponent, have its format. Always, if you want to write the number in exponent form or in a power form, always it will be like this. Product, let me write here, product is equal to base raised up by the certain exponent. That's why tuliandika 2 is equal to 2 exponent 1. Or we can write 8 equals to 2 exponent, something like this one. It means kwamba ili iwe power form lazima tuandike product is equal to base raised up by the certain exponent. That is a exponential form. Okay, so here we have two form. We have exponential form and the logarithmic form. Logarithmic form must be written in terms of log product base equals to exponent, and the exponential form must be written as the product is equal to base raised up by the exponent. Okay, let us check it here. Yeah, let us check it from our notes. Always the logarithm is represented in the form of log product, then here base is equal to exponent. For instance, this one log 8 base 2 equals to 3. This 3 is what we call the exponent, and this 8 is what we call the product, and this 2 is what we call the base. Okay, now assume a equals to b exponent c. So which one will be the base, which one will be the exponent, and which one will be the product? I think actually this one is a base. B is a base. That's why it's written here. Yani base siku zote inaandikwa kwenye. If you want to express a base, let me show you something. Always from this logarithm, base always is written here. That's why from this one, from our question, our base here is b. That's why log b here. That's why b is here. This means is base, and the product always is written in this region. After log, this region must be written the product. Okay, which is the product from this one? The product is a. That's why a is written as this position of logarithm, and it always is equal to exponent. Logarithm, any logarithm is equal to exponent. What is the exponent here? C. That's why is equal to c. Good. Okay, another one is this one. 8 equals to 2 exponent 3. We need to write this exponential form into logarithmic form. Okay, to write logarithmic form, as usual, you have to write log, then the product. What is the product? Product is 8, so log 8. Then base. What is the base? Base is 2. That's why you have to write 2 here is equal to exponent. Which one will be the exponent? The 3 is exponent. That's why it's equal to exponent. For this one, 81 equal to 3 exponent 4. So this 81 is a product, this one is a base, this one is exponent. As usual, log product. What is a product? 81. So have write log 81 like this one. Then base. What is the base? The base is 3 here. That's why we have to write 3 is equal to exponent. Our exponent is 4. That's why it's written like this one. Okay, let us move. This is a worked example. We're supposed to write this one in a logarithmic form. Okay, now be careful. Before writing this one in logarithmic form, you have to know what is this one, what is this one, and what is this one. Okay, let us classify. This one, 0.000 is equal to 10 exponent negative 4. This means your first number there is a product as usual. So this one, the first number is a product. So this is a product, and also this one is a base. So this one is a base, and this 4 is exponent. That is exponent. So because we know each and everything, base, exponent, and the product. Now we can write. Now this one is our product here, this one is our base, this one is our exponent. But in order to write the logarithm form, we're supposed to write log, then product, then base here, then is equal to exponent. Now log, what is the product? Your product is this one. So log product, base, what is the base? Our base is 10, so base 10 is equal to exponent. What is exponent? Our exponent is negative 4, as you see here. So just write is equal to negative 4. Okay, now this is a logarithmic form. I'm ready to convert it. It is very simple. Okay, second example. You need to convert this one into exponential form. Okay, so now it is a vice versa. To write into exponential form, you must have product is equal to base raised up by what? Exponent. This is the exponential form. Okay, now I have this one. From this one, which one will be the product? This is a product. What is this? It is base. What is this? It is exponent. So to write into exponential form, we have to write the product is equal to base raised up by the certain exponent. What is a product? My product here is 8. So 8 will be equal to base. What is the base? Base is 2. 2 exponent. What is exponent? Exponent is 3. 2 exponent 3, something like this one. So now our product is b8 is equal to base. Our base is 2, and our exponent there is 3. As you see, this one is exponent. That's why it's supposed to be exponent here 3. This 2 is a base. That's why we're supposed to write base here 2. And this one 8 is a product. That's why it's supposed to be written here. So important things is the format of writing the number in a logarithm key and the format of writing a number in an exponential form. Okay, claim it. If you want to write a number in logarithm form, always must be this one: log product base is equal to exponent. And if you want to write a number in exponential form, always must be like this one: product is equal to base raised up by the certain exponent. So do not confuse it. Just the rearrangement of position of this product, base, and exponent. Okay, let us shift. Let us shift to page number 3, this one. Okay, so now there's another question here. This one, you need to write into logarithm form. So this one is a base, this one is exponent, this is our product. So you need to write into logarithm form. So just make rearrangement. Kwa kuwa tunafahamu hii ni base, hii ni exponent, hii ni product. Logarithm form inasemaje? Logarithm form inasema kwamba log product base is equal to exponent. So just plug. What is the product here? The product is 1 over 125. So 1 over 125 here, you're supposed to write 1 over 125. Base, what is the base? The base here is 5. Base 5 is equal to exponent. What is the exponent? Our exponent is -3, is equal to -3. You are finished. It is very simple. Just to plug it. Okay? So from there, log product. This is our product. What is the base? Base is 5, is equal to exponent -3. It is over. Very simple. Even this one, this is a product, this is a base, this is an exponent. So to write into logarithms, you have to write log, then product. What is the product? This one, 0.1. Base, what is base? It is 10, is equal to exponent -1. Also, it is very simple questions. But also, you have to take your notes that. Take these notes. The logarithm of a number under base 10 is called the common logarithm. So sometimes it's what we call the decimal logarithm or base 10 logarithm. So you have to understand any logarithm with base 10, any logarithm with base 10 is what we call the common logarithm. This is called the common logarithm, or sometimes they call the decimal logarithm. Okay, or sometimes we call the base 10 logarithm also. So any logarithm with base 10 is what we call the common logarithm or base 10 logarithm, or sometimes called the decimal logarithm. So you have to understand it. It is very, very important. For instance, this one, log base 10 0.0001. This is a common logarithm because its base is 10 here. So any logarithm with base 10 is a common logarithm. Don't confuse it. Let me shift. Okay, now work the examples. You need to solve for x in each of the following. You need to solve for x in each of the following. Okay, let us check the first case here. This one. We need to solve for x. We know that x equals to log 100. It is given that x, let me write it well, x is equal to log 100. Okay. Also, you have to take a note that if there is a certain log without the base, it means automatical base is supposed to be equal to 10. So here, our logarithm doesn't have any base. This means our base here is 10. Take it in your mind, my friends. Always, if there is a logarithm without a base, put base equals to 10, and that is called the common logarithm or base 10 logarithm. So this logarithm doesn't have a base, that's why I'm introduced base 10 here. That is what you're supposed to do. Okay, then from there, I think this one, I can exchange this one. Instead of writing x is equal to this one, I can write log 100 base 10 equals to x. Log 100 base 10 is equal to x. Now from there, I think this one I can change it into exponential form. When I'm trying to change into exponential form, this one will be, it is my product, and this one, it is my base, this one is my exponent. So product is equal to base raised up by exponent. So I can write product 100 is equal to base raised up by exponent. When you try to convert the logarithmic form into exponential form, you will find something like this one. Then from there, you're supposed to think, this is 100, this is 10 exponent x. You have to make the same base the same exponent, or the same exponent the same base. So just think, this 100 is equal to 10 exponent what? I think by default, this 100 the same as 10 exponent 2, which is equal to, what is this? It is 10 exponent x. Then from there, we have the same base. Actually, we must have the same exponent. So you have to apply that concept. This 10 and 10, they are going to cancel. Left with 2 is equal to x. This means x is equal to 2. Okay, let us check the solution here. Will be equal to what? Okay, let us refer from this one. As usual, this number 10 exponent t is equal to 100. So I have to check this one will be equal to 10 exponent 2 in order to get 100. Then x will be equal to log 100 base 10. Then this one, instead of writing 100, you can write 10 exponent 2. Then from there, the same as log 10 exponent 2 is equal to this one. Now you can convert into exponential form. You will find 10 exponent 2 equals to 10 exponent x, the same base, the same exponent. At the end of the day, you will find the x equals to 2. But this is the first method. Also, there is an alternative method here. It is given that x equals to log 100. This doesn't have a base, that's why the same as base 10. And also, this one I can change into exponential form. Yeah, change into exponential form. When you change, you get 100, like this one. You get 100 equals to 10 exponent x, but this 100 is the same as 10 square. So 10 square equals to 10 exponent x. The same base, the same exponent. At the end of the day, you'll find the x equals to 2. But also, there's a second question here, given that negative 5 is equal to log this one under base x. Okay, negative 5 equals to log this one under base x. It is very simple. Negative 5 is equal to log 0.00001 under base x. So here you have to change this logarithm form into exponential form. Will be like this one when you change it. Change exponential form, change into exponential form. So if you change to exponential form, will be 0.0001 is equal to x exponent negative 5. Okay, so now you have to think about this one. Okay, this one the same as 10 exponent negative 5. Why it is the same as 10 exponent 5? We're supposed to check this number is equal to 10 exponent negative 5. Why? Because even when you want to write this number into standard form, will be like this one. How many steps you can shift? Let me check. First step, second step, third step, fourth step, 5 step for this direction. So exponent is negative. So this one into standard form will be equal to 1 times 10 exponent negative 5. But 1 times this one actually equals to this one. This one doesn't have any effect. So at the end of the day, that one equals to 10 exponent negative 5. That's why tukasema kwamba instead of writing this one, you can write 10 exponent negative 5, because 10 exponent negative 5 times 1 still will be 10 exponent negative 5. So now 10 exponent negative 5 will be equal to x exponent negative 5. So the same base, the same exponent as usual. For this case, we have the same exponent. Actually, we must have the same base as you see here. exponent negative 5 and exponent negative 5. That's why this also it's supposed to be equal to this one. This means x equals to 10. It is true, x equals to 10 there. Let us shift for this one. Given that x, given log x base 10 equals to 2, change into exponential form. We need to find the value of x. So to find the value of x here, it is very simple. First, try to change this one into exponential form. How to change? You have to know what is this one. It is a product. What is this? It is base. What is this? Is exponent. What is exponential form? Exponential form is written in form of product is equal to base raised up by the exponent. So now I can write what is a product there. My product is x. My product is x is equal to base. What is a base? My base is 10 raised up by the exponent. What is the exponent? Exponent is 2. So x equals to 10 exponent 2. So this means x equals to 100 because 10 exponent 2 find equals to 100. So also it is very simple. Just to convert into, you need to convert into exponential function, into exponential form, then you will solve it. Okay, let us check the second example here. You have log x base 8. This one is equal to 2. As you know, when you're writing the number into logarithm form, let's say when you write log x, as you see here, log x base 8 equals to this one. Actually, this x is what we call the product, this 8 is what we call the base, and this one is what we call the exponent. So you have to convert into exponential form. When you convert it, will be the product is equal to base raised up by the exponent. So into exponential form will be like this one. Product is equal to base 8 raised up by the exponent. Your exponent here is 2. This means x will be equal to 8 squared. You get 64. So x equals to 64. It is very simple. Just to convert from the exponential into logarithm into exponential. It is very simple questions. Okay. Then from there is another note here. If you have log 100, this 100, check out this, you have log 100, but this 100 the same as 10 square, so log 10 square. But also this logarithms doesn't have a base. It means the base here is 10. Okay, so since here there's a base 10 and here there's 10 square, so this 10 square, 10 and the base 10, they're going to cancel. So this 10 and the log base 10, they're going to cancel. You're left with this 2. That means if you have log 100, this one the same as log 10 square, there's no base here. This means under base 10. Then from there, this 10 they're going to cancel with log base 10. So you're left with 2 as your answer, right? Okay, so what you're supposed to do, this log 100 will be equal to 2, something like that. Let me delete something. Okay, how about this log 10? How about this log 10? The same as the previous. This is log 10, but this log 10 is the same as 10 exponent 1, so it will be like this one. You have log 10, log 10. This log doesn't have a base. It means your base here is what? Your base here is 10 because it doesn't have a base. Okay, but also this one the same as log base 10, and this one the same as 10 exponent 1. Okay, because this 10 they're gonna cancel with log base 10. Now you're left with 1. So log 10 equals to 1. Very simple also. Okay, let me delete it. Okay, that's why log 10 will be equals to log 10 square, log 10 exponent 1, which is equal to 1. Okay, log 1, this one the same as log 10 exponent 0, which is equal to 0, because this 10 they're going to cancel with log base 10 here. The same as this one, log 0.1, the same as log 10 exponent negative 1, because this is 0.1 the same as 10 exponent negative 1. But this 10 they're going to cancel with this 10 from the base, and we're left with only negative 1. So the answer is negative 1, and so on. So log 100 the same as 2, log 10 square the same as 2, Log 10 exponent 1, the same as 1. Log 10 exponent 0, the same as 0. Log 10 exponent -1, the same as -1. Even log 10 exponent -3, the same as -3. This means even if you have log 10 exponent 7, still will be equal to what? 7. Even if log 10 exponent 100 also will be equal to what? 100. Okay, I think kuna kitu utakuwa umejifunza hapo. Kwa hiyo kumbe zile exponent ndio zinaenda kuwa majibu. Okay, but this one is applicable only for the log base 10. Okay, so now let us take the general concept. General log base 10 for the 10 raised up by the certain exponent will be equal to n. Hii inamaanisha kwamba popote pale tutakapokutana na log, let's say popote pale tutakapoona log base 10 and also there is a 10 exponent something, your answer here will be equal to that something. So just to claim it, if you have log base 10 and the 10 exponent something, your answer will be equal to something like this. Let me repeat it. If you have log base 10 and the 10 exponent something, let's say exponent x, your answer must be equal to that x. Even if you have log base 10 and this is 10 exponent thousands, your answer must be to that thousands, something like that. Okay, so you have to understand it. That's why here we develop the general concept. That if you have log 10 exponent n, that one will be equal to n because the base here is base 10. Find log thousands. Okay, let us check the question. Find log thousands is equal to log 10 exponent 3. Because log thousands equals to log 10 exponent 3, then because this is 10 exponent 3 will be equal to 3 itself. Because here we have log base 10, they're going to cancel with this 10, now left with 3. It is over. That is something like this. It is log 10 exponent 3. Doesn't have a base here, means base is 10. Okay, because here base 10 and this one is 10, this one is going to cancel this log, now left with 3. That's why here the answer equals to 3. Okay, let me shift. Now it is exercise, so take your time to finalize this exercise, and I will mark the question, so make sure you collect your task. I'll mark it through WhatsApp as usual. Final, I'd like to remind you, make sure you subscribe to my YouTube channel called Some Form Online, but also the situation is as you see here. Make sure you wash your hands all the time. Thank you.